Okay, today we're going to talk about solving single variable equations. So solving single variable equations. Okay, a single variable meaning anything. Any variable that represents a number or numbers. For example, if we take the equation 2 times the quantity of x minus 3 plus 4 times the quantity of 1 minus x, and we set that all equal to 0, then we're looking at solving an equation with a single variable, x. So our variable is x. So if we solve for the single variable x, we can use, in this case, the distributive property, 2 times x minus 6 plus 4 times 1 minus 4x equal to 0. Okay, so we have 4 terms on the left-hand side, and what we want to do is combine our like terms. Okay, so we're going to combine our x's, our variables, and our constants. So 2x minus 4x is negative 2x, and then negative 6 plus a positive 4 is minus 2, and that is equal to 0. Now we have a two-step equation where we're going to add 2 to both sides to solve for x. And when we do so, that cancels out. We're looking at inverse operations. The inverse of subtraction is addition, so we're going to cancel out on the left-hand side, but on the right-hand side we're going to drop down our plus 2, or just 2 is sufficient. And on the left side we have negative 2 times x. So we have negative 2x is equal to 2. Again, we're going to use inverse operations of multiplication. The inverse operation of multiplication is division, so we're going to divide both sides by negative 2. And what that does is that cancels out the negative 2's on the left-hand side and leaves us with x equal to 2 divided by negative 2, which is negative 1. We can check our solution by plugging in the value of x at negative 1 back into the original equation, and in this case it should work. So negative 1 times, or negative 1, plugging that back in, excuse me, negative 1 for x is negative 1 is negative 4. Negative 4 times 2 is negative 8. And over here we have 1 minus a negative 1, which is 1 plus 1, which is 2. And 4 plus 2 is 8. And negative 8 plus 8 is, in fact, 0. So it checks. So, great.